Alright, so this here is a quick video that I would like to do on parallel and perpendicular lines when we're talking about the equations. And so I want to start off with this little picture here of what you can see here is it's a graph of, it looks like we're comparing the hours worked with the amount of money earned. So if you look at the top line here, this is Madison's so how much Madison makes and for the hours worked. So if you look here, um, Madison, it looks like Madison started at 25 right here on the amount earned, and that means that she started out, she already had $25, and according to this, she had a $25 bonus to start. And then after every hour, it looks like she went up. We'll say for 1 hour from right here to right here. Looks like she went up about $10 from about 25 to 35. And over one, so that would be about $10 per hour. And you can see that there in the equation, 10 times x, or 10 times however many hours she works, plus the 25, which was her starting point. Now, if you look over here, this line also looks like it's parallel. It looks like it has the same exact thing. You go up 10 over 1, so it's $10 per hour as well. You can see that in the equation. But there's no, there's no starting point. So started with 0. So it has the exact same rate, the exact same slope if you look at the line, even though they start at different points. But that means that they're parallel, having the same rate of increase here. Okay, so parallel lines, this is something to note. Parallel lines have the same slope. Now, if you look at this, I can draw one on here. It's not going to be perfect, but a perpendicular line to this would look something like that, going through here. So it makes a right angle. Now, this isn't applicable exactly to this example, but if you look, instead of it being a positive slope, like if you looked at the line to the right, it's a positive 10 up over 1. This one looks like you go down, so it's a negative slope, first of all. And if you go down, if you go down 10, or sorry, when you go down 1, it looks like you go over quite a bit. Um, and so the slope would be the reciprocal of 10 over 1, which would actually be 1 over 10. And that's not something you can see exactly from the slope, but you can see that it's the opposite, which would be negative. So perpendicular lines have the opposite, and when I say opposite, I mean the negative, reciprocal slopes. So for them to be perpendicular, they have to have opposite reciprocal slopes. For them to be parallel, they have to have the same slopes. And we can deal with that with looking just at equations. So I'm going to work through an example or two from what we have here. So the question says, write the slope-intercept form. So first of all, we're going to write slope-intercept form, which is, I'll move this down a little bit, which is, as we know, y equals mx plus b, where m is the slope and b is the y-intercept. So we're going to write it in that form of the line that passes through the given point. So each one has a given point and is parallel to the graph of each equation. So that means for it to be parallel, we have to find the same slope. So we look back here, it has to have the same slope. Okay, if it has the same slope, we just have to plug in for the line that we have that we're looking for. So let's say we look at number 7. You know what? Never mind. We're going to look at number 6. Number 6, we have, it says there's a given point, 3, -1. We want the line to go through that, but we also want it to be parallel to 2x plus y equals 5. Now, if you look at 2x plus y equals 5, we don't know what the slope is yet because it's not in a form that shows the slope. It's not in slope-intercept form. It's not in point-slope form. So we're going to first try and get that into point-slope form by isolating the y. So to do that, we have to get rid of this 2x on the left side. So we'll subtract 2x from here. And then we have to do that to the left, to the right side here. All right, this will cancel out. You're left with y, positive y equals. So it's 5x plus negative, or 5x plus 5 plus negative 2x, or we can switch it around and say y equals negative 2x negative 2x plus 5. So then it's in our slope-intercept form. All right. Now from there we know that the slope is what's before the x, so the slope here is -2. And we can use that in our new equation with the given point to find the graph of the line that's parallel. So we're going to start by, I'll minimize this a little bit here. If you want to pause it, you can, but I'm going to make these smaller so we have some room off to the right here. There's our work there. We're going to take the slope from that, and we're going to use point slope form here. Because we have a point, we also have the slope. So we have this point, I'm sorry about that, we have this point, and we have the slope. So that gives it a way that we should use point slope form. So, point slope form. Point slope form, you need a point 3, 1, which would be our x1 value and our y1 value. And then the slope is -2. So, for point slope form, I'll write it right here. It's y2, or y minus y1 equals m, which is the slope, times x minus x1. And we're going to be plugging in for the slope and then also the x1 and y1. So to do that, let's put in m for the slope here. -2 goes here. That'd be x minus, let's see, what is x1 is 3. That is equal to y minus y1, which is 1. Now, this is a totally good equation of a line. That's all that I need you to do is to be able to put it into at least point slope form. But if you want to take it one step further, you can look at that and you can say, let's put it into slope-intercept form, like it actually asks you to do here. Put it into slope-intercept form, y equals mx+b form. And first you'll have to, if you remember, distribute here. Distribute the -2 to the x, and the -2 to the -3, which would be make a +6. Y minus 1 equals +6, or -2x plus +6. And then there's one more step to get the y by itself, and that would be adding 1 to both sides. You can add 1 there, add 1 there. You're ending up with y equals -2x. Sorry. -2x plus 7 we have. And then it is in slope-intercept form. So the big keys here are, one would be to have your original equation in slope-intercept form so that you can figure out the slope. And that's where number 2, determine the slope. Again, slope is really easy in slope-intercept form because it's just the number before the x once it's in the slope-intercept form. And then 3 would be to plug in for and you're plugging in for plug in the point x1, y1, whatever you're given there, and m for point slope form. Since you have a point and you have a slope, use point slope form. And then you can go from there. Now, what I'm going to look at now is the second thing. Now that we've gotten it down for parallel lines, you also need to be able to do it for perpendicular lines. So I'm going to copy this here. Because this second example here deals with, it says almost the same, write the slope-intercept form of the equation of the line that passes through the given point. This time it is perpendicular to the graph of the equation. So we're going to look at, let's say, number 15. How about? And what I'm going to do here real quick is I'm going to copy and paste these directions back in here. But I'm just going to change one thing here. And that one thing is going to be actually going to be a new step 3. So if you look back here, we said the only difference between parallel and perpendicular lines have the same slope. Perpendicular lines have the opposite, or the negative, and the reciprocal slopes. So we have to, instead of just using the same slope, we're going to use the opposite reciprocal slope. So looking right here, I'm going to add into, this is going to be our new step 3. Make opposite reciprocal slope. So if you're looking at number 15, we're going to use the same steps, only we're going to use a different equation. So we have -4, -3 is our point that we're given, that we want to go through. We're also given, okay, stop. We're also given the equation 4x plus y equals 7, which is very similar to last one. Now, first of all, put it in a slope-intercept form so we can find that slope. And to do that, we have to subtract 4x from both sides to get the y by itself. Cancels out here. You have positive y equals, it'd be 7 plus -4x, but I'm going to flip it around right away. So it's -4x in front plus that 7. So we have it in slope-intercept form. Now, so that's step 1. Now step 2 is to identify the slope, which in this case m equals -4. It's that number that comes right before the x. Now step 3 is a new step 3, and I'm going to change this right here to step 4. Step 3 is make the opposite reciprocal slope. So that means if this is -4, it's actually -4/1. So opposite, so this is the new slope. Means it's going to be positive, and it's going to be the reciprocal, and that means flipping it. So reciprocal means to flip. So it's going to be the 1 on the top and the 4 on the bottom. So we have it, the reciprocal there, and then the opposite means that we're going to do the, if it's negative, we're going to make it positive. So there we go, that's the new slope. And now step 4, you have to take the point -4, 3, or -4, -3, which would be your x1 and your y1, and then m equals 1/4, and put them into point slope form. which point slope form, as we said before, is y minus y1 equals m times x minus x1. All right. So we'll plug that in, y minus y1. So we have y minus our y1, which is negative 3, equals m, which is 1/4, times x minus x1, which is negative 4. Okay, and now the only thing that you need to do to finish this is to change the two negatives next to each other into two pluses, because two negatives become positives. And you are good to go. Now, if you really like to, like in the last example, we said before we could take this and put it into slope-intercept form at the end to change it up. You can if you want. You do not have to. Either way, as long as it's in a form of an equation, of a linear equation, either point slope or slope-intercept form, that is acceptable. So again, this is just a quick review of how you can deal with parallel and perpendicular lines and their equations. All right. So I hope this helps. Have a great time.